Assalamualaikum and hi. My name is Ahmad Salahuddin bin Amir and my ID is EB19 and 331.
Okay, for the project background, I will tell you about the cooling system. Okay. Every type of a machine or transport need cooling system to make sure the engine is not overheat. When engine is overheat, engine will break down. Also that cooling system is divided by two types, air or liquid. It because to remove heat with from the internal combustion engine. For small or special machine, cooling using air from the atmosphere make the system light and in good condition. Number 2 is the cooling system serve three important functions. It is to make your engine is in a good condition to use. First, it remove excess heat from the engine. Second, it maintain the engine operating temperature where it work most efficiently, and finally, it bring the engine up to the right operating temperature as quickly as possible. Okay, this is our flow chart. First of all, I will tell you a definition of a flow chart. First of all, a flow chart is a type of a diagram that represent a workflow or process. A flow chart also can be defined as a diagrammatic representation of coding and a step-by-step approach to solving a task. Okay, we go to this flow chart is when we turn on the first switch, the temperature is working. When temperature detect that temperature is bigger than 30 Celsius, the buzzer make a sound, red LED blink, and the LCD will show danger, and motor is on. Motor actually like our cooling system in the system or in the engine. Okay. When temperature is below than 30, the green LED will light up and LCD will show safe. Okay. When we turn off a switch 1 and all of the component is off. When we turn on the slide switch 2, the emergency light is on. That emergency light is like indicated that the situation is in the system is safe. Okay, that's all for the flow chart.
Assalamualaikum, my name is Muhammad Fahami Mazuki, EB19169 from section ED30. I would like to explain about list of component and specification in this circuit that we have set up for cooler system simulation. There are 13 of components that we have used in this circuit. First of all, one of Arduino Uno R3, DC motor, one light bulb, one breadboard, a lot of jumper wire connector, two slide switch, one temperature sensor, green and red LED, one of 16 multiply 2 LCD, one of H-bridge motor driver or IC that capable of running 2 DC motor, one of piezo buzzer, 6 of 220 ohm resistor, and finally one of potential meter. I also have made a list of full detailed specification for each component in this slide. Next, I would like to explain about block diagram. A block diagram is a diagram of a system in which the principal parts or functions are represented by blocks connected by lines that show the relationship of the blocks. They are heavily used in engineering in hardware design, electronic design, software design, and process flow diagram. So, this is the block diagram that our group has made, referred by the final circuit that I have shown before. So, first of all, we must know the difference between input and output components. The arrow for the input components the arrow will always show into the Arduino because the input components will send the data to the Arduino, such as slide switch 1 and 2, temperature meter and potential meter. While the output components, the arrow will always go outwards from the Arduino, such as DC motor, LCD, red and green LED, bulb and buzzer, because the output components will receive the data from the Arduino. So that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim Muhammad bin Rosli. My metric number is EB19171. Now, I want to explain our circuit and coding software for cooling system.
Okay, this is my cooling system. The component that has in this system like a DC motor, potentiometer, Arduino, buzzer, LCD, red LED, green LED, 2 slide switch, light bulb, TMP36, H-bridge motor driver, and resistor. Now I want to show the coding software. The output is green LED that I connect to pin number 8, red LED I connect to pin number 9, buzzer I connect to pin number 10, motor the H-bridge motor driver I connect to pin analog 1 and analog 2, and then the input is the TMP36 I connect to analog 0, the slide switch I connect to pin number 6 and pin number 7. So here LCD will display the cooler system. So I want to highlight here, this is the convert the voltage to temperature in degree Celsius. So when the system on, the cooling system will detect the temperature from the device or the machine. When the temperature less than 30, the LED will on and the LCD will show safe. That means the machine or the device in a good condition. When the temperature in this machine or device are equal or greater than 30, the system will, the red LED will blink and the LCD will show danger. That means it can notice to people around, and also the buzzer will on and give a sound to alert. At the same time, the system will active the DC motor. The DC motor can be a fan or anything to reduce the temperature until the temperature less than 30. When the temperature less than 30, the green LED will on. The LCD will show safe. That means the device or the machine in a good condition. So let's start. Okay, let's say the device or the machine on, the cooling system also on. So this system can detect the temperature. So when the system detects the temperature from device or machine less than 30, green LED will on and the LCD will display safe. That means the device in a good condition. When the temperature in the device or machine greater than 30, The red LED will blink and the LCD will show danger. At the same time, the buzzer will on to give alert to other people or people around. And also, the DC motor will on. The DC motor will on as a fan or a cooler to reduce the temperature in the machine or device. So the system will avoid from damage until the temperature reduced. But when the device or the machine cannot avoid from biggest problem, so the system can be off and then the system have a backup, like backup or voltage backup, such as this is the emergency light, or it can be the power backup or power supply. The conclusion is each device or machine must have this cooling system to prevent the machine or device from damage and maintain the operating temperature. In addition, it can facilitate maintenance work to prevent the occurrence of injury due to overheating. It can also prevent some components in the device rather than damage. The system can maintain the durability of the machine for a long time and can reduce maintenance costs. That's all from our group. Thank you.